Okay, we're going to do problem 2.1.17, which is related to problem 2.2.15. Same problem, different approach. So heights of statistics students were obtained by a teacher as part of an experiment conducted for the class. The last digit of those heights are listed below. Construct the frequency diagram with 10 classes based on the distribution. Okay, so let's do the frequency distribution. Let's see, there's 2, 4, 6, 8, 9 zeros. So this is ranked data. It's already ordered. 1, 1, 1, 2, 3 threes, 2 fours, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 fives, 1 6, no sevens, 3 eights, 1 9. So there's your frequency distribution. So the classes are just the individual numbers. It's numerical classes, but they're just the individual numbers. So the question is, based on the distribution, do the heights appear to be reported or actually measured? So you get your feeling for what they're asking by looking at the answers. The heights appear to be actually measured because there are disproportionately more zeros and fives. If they were accurately measured, they would be all equally likely. You'd expect that there would be just about as many in each class. Let's see, there's 10, 11, 16, 26, 27, 31. You'd expect about 3 for each class if they're equally likely. But they're heavily overloaded in the zeros and fives, which tends to say C is correct. The heights appear to be reported because they're disproportionately more zeros and fives. What that means is people are rounding off. They're just rounding them off to zeros and fives. Remember, this is the last digit of the heights, whether it's in, you can assume it's inches or centimeters. At any rate, that's what's going on here. They're rounding, because if they weren't rounding, you'd have a more uniform distribution. In fact, we can go ahead and check the distribution. If I just open this in StatCrunch, since we have the raw data, I can go ahead and graph histogram, variable 1, that's where the data is, and then bins. Well, we have to go a half a unit below the first class. The first class is 0, so we start at negative 0.5, and negative 0.5, and the width is 1 unit. And when I draw them, there's your histogram, and you can see that obviously the zeros and the fives are disproportionately high. If it was uniform because they're equally likely, it'd be flat across the top. All's like 2 3s and 4s, average of 3s, let's say. So what can be said about the accuracy? Well, they're not very accurate because they appear to be reported. Look at the other distractors. They're likely not very accurate because they're actually measured. Well, if they were actually measured, they would be very accurate. They're likely accurate because they appear to be reported. No, if they're reported, they're not accurate. And they're likely accurate because they appear to be actually measured. Well, we know that they're probably not actually measured, once again, because they're not equally likely. So they're not very accurate. That's the whole point, that they're rounded. And that is a conclusion drawn from the distribution. You can look at it numerically in the problem, or you can look at it on the histogram. It's pretty obvious that it's bimodal, zeros and fives, which means those are the most popular answers. And that means that they're probably rounded, especially if they're using something like centimeters, because there's 2.5 centimeters per inch, typical height of a, say, a student. Let's say it's 5.5 feet. That would be 66 inches. You're looking at something like 130 centimeters or so. So anything that's 134, they would round it to 135. That's where these zeros and fives come from. 128 becomes 130, for instance. All right, so if you look at problem 2.2.15, There they give you the frequency distribution and ask you to draw the histogram based on the, well, you can select the correct histogram from that. I suppose I could open it up and show it. Let's look at it. 2:15. So you see, this is a very similar, it's twice as much. We had 31, this has 65 for N, but you can see that it's bimodal, zeros and fives. And so if you look at it long enough, you can figure out that I think B is the right answer. Is that correct? Yeah, I think B is the right answer. No, B is not the right answer. Let's see which one is. Oh, C. Okay, C is the right answer. All right. So it's bimodal. This leads you to believe that the data appears to be reported. So it's either B or C, or a B or D. So B says the heights are roughly the same, but that's not true. In D, the heights are roughly the same. That's one that's pretty uniform. So it has to be D. Okay, so there you go. This is Dr. K, over and out.